Now that we know something about polar coordinates, let's take a look at how we might relate what we already knew about rectangular coordinates to the polar coordinates and do a conversion from one to the other. So let's talk about what we already know. What is the connection between x, y, r, and theta? And specifically, if we are given a rectangular coordinate that is in the form of x, comma, y, how can we find the r and the theta that would convert to? So using this right triangle that we see in this image, I think will help, because what we already know is that if we're given an x value and we're given a y value, then we can find an r value, can't we? And we can do that by the Pythagorean theorem. And the Pythagorean theorem would say that x to the second plus y to the second is equal to r to the second. So therefore, given an x and a y, we can find r, can't we? What else do we know? Now that we know x, y, and r, how can we find theta? Well, we know that there are some right triangle properties that relate x, y, and r to theta. And those right triangle properties are that the tangent of some angle theta is equal to y over x. Those were the SOHCAHTOA rules that we learned in an earlier section. We also know that the cosine of some angle theta, do you remember what that ratio is? That was x over r. And we also know that the sine of some angle theta is equal to y over r. So using any of those combinations, we can then locate and determine what theta is. So given a rectangular coordinate, x comma y, we can find the polar coordinates r comma theta. Let's take a look at an example. So let's look at this example. Part A, convert the rectangular coordinates square root of 3 comma 1 to polar coordinates. Then plot on both graphs. What both graphs are we talking about here? Well, we're going to end up graphing the rectangular coordinates square root of 3 comma 1 on a rectangular coordinate system. A rectangular coordinate system is just your normal horizontal lines, vertical lines, all those little squares. And what we want to make sure of is that if we then convert that rectangular coordinate into polar coordinates and we plot the polar coordinate, that it's in the same location as what we saw with the rectangular coordinate. So for example, I can see that this rectangular coordinate square root of 3 comma 1, because it's a positive x value and a positive y value, that I'm going to end up in quadrant 1. Okay, so what that means is that whatever my polar coordinate happens to be, I better end up also in quadrant 1. And maybe we want to plot that point right off the bat on the rectangular coordinate system. Let's see here. Square root of 3 comma 1, let's just do that. Square root of 3 comma 1 is some positive, let's look at the x-axis here. It's some positive x value, and you might want to just put into your calculator, what is the square root of 3? As a decimal, the square root of 3 is approximately, what is it, 1.73, 1.73. So I'm going to go on the rectangular graph, I'm going to go positive 1, there's positive 2, so it's going to be around, a little bit closer to 2, isn't it? And then I'm going to go up 1. So I'm going to go up 1. So here is 1, and here is on the y-axis, and then here's 1 on the x-axis, and here's 2 on the x-axis. Overlaid on top of that rectangular coordinate system is the polar graph. Okay, we'll get to that in a minute. All right, so we have been given an x, and we have been given a y, and what we want to do is rewrite that x comma y as an r comma theta. And we're going to use the things that we just really noticed on the previous slide about the relationship between x, y, r, and theta. Okay, so if we're given x and we're given y, we can find r, right? So I'm going to write that square root of 3 to the second power plus 1 to the second power is equal to my r to the second power. So that gets me 3 plus 1, and so I'm going to have an r value equal to 2. All right. Now, knowing that my r value is 2, I can either use the tangent of theta or the cosine of theta or the sine of theta to come up with the actual value for theta. Let me show you what I mean by that. Most books are going to tell you to use tangent. And the reason why they say to use tangent is because you have been given the x and the y, right? You've been given the x and you've been given the y. And the other two, the cosine and the sine, involve a radius. And if we have messed up with the calculation for the radius, then we're going to mess up with the angle measure as well. So using just what's given to you, I would say that the tangent of theta is equal to 1 over the square root of 3. And if you know what angle measure produces a tangent equal to 1 over the square root of 3, you can do that without a calculator, then go ahead and use tangent. If, however, you don't have that memorized, then let's look at cosine. And if I feel pretty confident with my radius of 2, I'm going to say that the cosine of theta is equal to my x value of square root of 3 over my r value of 2. Okay, now if these are not angle measures that we have memorized, then you might as well just use tangent and put it into your calculator, right? You'd be putting into your calculator inverse tangent of 1 over the square root of 3, and it would give you some angle measure. But if you're not being allowed to use a calculator, or if you know that it's an angle measure that is one of our common or regular angle measures, then maybe using cosine or maybe even using the sine might be the way to go. So the sine of theta would be my y value, which is 1 over my radius of 2. Now, I don't know about you, but I definitely have those two memorized. The angle that produces a sine of 1/2 and also produces a cosine of square root of 3 over 2 is an angle measure of, do you have that in your head? That would be an angle measure of pi over 6, I believe. So what that tells me is that my original rectangular coordinate of square root of 3, 1 as a polar coordinate is going to be, let's see, what is that going to be? That's going to be a radius of 2 and a theta of pi over 6. Now let's make sure that we've done that correctly. Take a look at the graph, the rectangular graph where we plotted the point, right? We said that that point was about right here. And if I take a look now at the overlay of the polar system, I can see that pi over 6 is in the first quadrant. And if I draw that directed line segment through pi over 6 and I go a radius of 1 and I go a radius of 2, it is in the same location. And that's good. That's what we want. So on a rectangular coordinate system, square root of 3, 1 is in the first quadrant, and that matches on a polar coordinate system, the polar coordinate of 2, pi over 6. Let's look at one more example. This one says to convert the rectangular coordinate 0, -2 to polar coordinates, then plot both on the graphs. Now, we can definitely go through the same process that we just did, where we are being given some x value and some y value, and so therefore we can do x squared plus y squared equals r squared, and then we can either use tangent, cosine, or sine to find theta. But when you have a point that lies on an axis, right, that's what's happening here, because 0, -2 is going nowhere on the x-axis, and then it's going down 2 units, right? There's the point, 0, -2. When we have a point that lies on an axis, as opposed to pi over 6, that point was not lying on an axis, it was lying on a diagonal. But this one is lying on the negative y-axis. Then we can just simply look at it and identify what the angle measure would be to get to that point, right? Like look at the circle. We know that on the circle that the positive x-axis is at 0 radians, the positive y-axis is at pi over 2, the negative x-axis is at pi, and the negative y-axis is at 3 pi over 2. So maybe you would agree that 0 comma negative 2 is at an angle measure of 3 pi over 2. And in order for it to stay at 3 pi over 2, we would have a radius of 1 and 2. So moral of the story here is, if your point lies on an axis, then you can just identify what the radius is of the location of that point, and what the angle measure is. So my angle measure I saw was 3 pi over 2, and that was at a radius of 2. That's going to be my r, and that's going to be my theta. Now, again, if you want to go through the process of plugging it in and doing the x squared plus y squared equals r squared, and then using tangent, cosine, or sine to find the angle, you totally can. One thing that you might be asking yourself right now is, why did I use 3 pi over 2? Could I have written it in a different way? And yes, absolutely, as we saw in previous videos, maybe I would have wanted to write it as negative pi over 2 and a positive radius of 2. That would have also gotten me into the same location. What's another way? Another way could have been, maybe I'm going to go up to positive pi over 2. I'm going to go up to positive pi over 2. Well, in order to get back down to that negative y-axis, then I would have to go the opposite direction, which would making my r value a negative. So as long as the polar coordinate that I come up with maps the same location as the rectangular coordinate that was given, then that's a possible polar coordinate, and I can use it. Now let's take a look at an example similar to what we've looked at before, but taking it really step by step to make sure that we understand it. Step 1, plot the rectangular coordinate, negative 3, 3, on the rectangular coordinate system. And this point is in which quadrant? All right, so the rectangular coordinates, negative 3, 3, so we're being given an x value and we're being given a y value. So on the x-axis, I'm going to go 1, 2, and 3 to the left. And on the y-axis, I'm going to go up 1, 2, and 3. And that's going to put me at a point that's in quadrant 2. All right, remember we're trying to, ultimately we're going to convert this rectangular coordinate to polar. Right now we're just plotting the point. Part B, from the pole, so the pole is the origin, 0, 0, draw in the terminal side of the angle theta. So from the pole, I'm going to draw in to that point a terminal side. And when we talk about a terminal side, we have to have an initial side. So on the polar axis, I'd be starting on that positive x-axis. The distance from the pole to the point is the radius r of the circle that goes through that point. Okay, hasn't asked us to find it yet, just to mark it on there. Part C, we know that the relationship between x, y, and r is that x to the second plus y to the second is equal to r to the second. So we're going to use that to solve for r. So I'm going to write that negative 3 quantity squared plus 3 squared is equal to r squared. So that's going to give me 9 plus 9, which is 18. 18. So r is going to equal the square root of 18, which is the square root of 9 times 2, and we're going to write that in simplified form as 3 root 2. And 3 root 2, by the way, is approximately 4.24. I like to have that approximate in there if I'm going to be asked to graph this. All right, part E. The relationship we know between x, y, and theta is that, let's see, the tangent of theta is equal to y over x. Okay. And now we want to solve for theta. And we want to remember that we want to make sure that we consider the quadrant of the original coordinates in order to make sure that theta is correct. Let me show you what I'm talking about here. So if I'm going to solve for theta, I'm going to say that the tangent of theta is equal to my y value, which is 3, over my x value of -3. So I'm going to have that the tangent of theta is equal to -1. Now, if you think about this in terms of, okay, I need an angle that's in the second quadrant that gives me a tangent of -1, I think you'll come up with it no problem. I think that you'll see that that angle measure is 3 pi over 4. But if you simply put into your calculator inverse tangent of -1, the calculator is going to produce for you the angle measure of -pi over 4. And that's because of the way the calculator is set up to only give you a response from pi over 2 to -pi over 2. So the calculator is giving this response in the fourth quadrant. If you just blindly use that, you don't think about where the angle actually ends up, you're going to get a lot of wrong answers. So what you have to remember, if you're going to use a calculator, is that whatever angle measure you get, is it in the right quadrant? And if it's not, then what I want to do is add the period of the function, which in this case is the tangent function. I'm going to add pi to that so that I can get into the right quadrant of 3 pi over 4. Now, I think I'm going to run out of room here. Yeah, I just went over that. So let me erase that. You saw me do it. Let me just erase it. And I'm going to say, what did we say? We said that theta is going to equal 3 pi over 4, right? So the polar coordinate will be that 3 pi over 4, and we'll have a radius of 3 root 2. It's a little hard to squeeze that in. So let me go ahead and plot that. So 3 pi over 4 we know is in the second quadrant. And then we're going to go from the pole, we're going to do a radius of 3 root 2. Now, a radius of 3 root 2, we said is about 4.24. So we're going to go on this directed line segment, we're going to go a radius of 1, a radius of 2, a radius of 3, a radius of 4, and I can believe that 4.24 is in the same location as the original rectangular coordinate of -3, 3.